Welcome to Wildcat Science with Mrs. Haugo. This is Physical Science, Chapter 1, Forces, and we are in the 1.2 lab, Part 2. So previously in Part 1, we started the lab and we obtained a jug and a spring scale, and we marked the position of the spring scale at 0 with an empty jug, and then we added 100 milliliters 5 times, and then we got that. And we answered some questions, and then we did the same thing with the jug, except now we use 200 milliliters as the weight of 200 milliliters of water as our scale, and we got that. And then we obtained object 1, and we measured its weight with the round 1 spring scale, and we measured its weight with the round 2 spring scale, and we found on round 1 it had a weight of 3 special weight units, and we put that in our data table. And we found in round 2 it had a weight of 1.5 special weight units, and we put that in our data table. So we did 17, 18, 19, 20, and now we're ready for 21. So it says to remove the masking tape from the spring scale. Well, it's a little bit sticky. Okay. And then Q7, did all of the groups or rounds report the same weight for object 1? Well, clearly they did not, because our scales were different. So using a race sentence, all groups did not report the same weight because, and then you'll want to explain your answer. Okay, part C, we're going to re-zero our spring scale if needed. So I'm going to re-zero it so that the top of the springs of the force indicator is right there at 0. And there it is. And then I'm going to pull carefully on the spring scale with 1 Newton of force and no more. So let's get that so you can see it. And I am not pulling very hard at all. Then, without weighing them, I'm going to predict the weight of all 3 objects and put the predictions in the data table. So let's start with 1. And that's quite a bit heavier, so I'm going to say 3 or 4. So let's say 3.5 newtons. So 3.5 newtons, please write that there. And then object 2 is not as heavy, but it's still heavier than 1 newton. So let's say maybe between 2 and 3. So let's write 2.5 newtons. So please write 2.5 newtons here. And then object 3 is the lightest of all of them. So let's say 1 newton and write 1 newton here. Okay, so that was number 24. Number 25. Weigh the 3 objects with your spring scale and record data in data table 2. If you haven't made predictions for all 3, stop, go back and make predictions first. So let's start with the weight of object 1. So I'm going to put object 1 on the spring scale, and then if you can see, it is So the division of each of these, 1, 2, 3, 4, 5. So there are 5 little divisions between 2 and 3. So the value of each division is 0.2 newtons. So it is 2.8 newtons. So please write 2.8 newtons right here. Now for object 2, I'm going to take the weight, they're different, of object 2. And you can see it's in between 2 and 3. And it is 2.2, 2.4. So put 2.4 newtons right there, please. And then I'm going to do object 3. I'm going to take the weight of object 3, and you can see it's right about 1. I would say 0.8. So put 0.8 newtons right there. Let's go to the questions. Q8 says mass versus weight. It is important to remember that mass is the measure of the amount of matter in an object, and it is measured in kilograms. Weight is the measurement of the force of gravity on an object, and it is measured in newtons. Mass and weight are different. Even though we often, in common language, use them interchangeably, they are not the same. So mass is the amount of stuff in this or anything, and weight is the force of gravity on this. So if we were to take this to Mars, its mass would stay the same. It would have the same amount of stuff in it, but its weight, the force of gravity on it, would be different because acceleration due to gravity on Mars is different than it is here on Earth. Okay, so coming back to the question, using your weights from data table 2 as a guide, what is an object that would have a weight of about 1 newton? You can't say object 3, sorry. And then a hint, you want to click on this link and it'll give you some, if you read through it, it'll give you some examples of objects that have a weight of about 1 newton. So let's talk about the race answer. We would want to restate the question. An object or objects that have a weight of about 1 newton are, and then you would fill that in. Okay, you can pause the video while you do that. Moving on to the purpose revisit. Why is it important that all scientists all use a standard weight unit, the newton, instead of different units like the special weight unit, and explain using evidence from our lab? So we measured the weight of objects using our standard weight unit, newtons, and then previously we had measured the weight of an object using just our own weight unit that we made up, a special weight unit, and it actually differed because round one, it was the weight of 100 milliliters of water was 1 SWU, and round 2, the weight of 200 milliliters of water was SWU. So I assume you could figure out why it would be an issue if we measured the weight of the same object and we got different weights. That would not work very well in science. It's hard to communicate if we're using different units and we don't know what those units are. So if I say the length is 5, I don't know what you're talking about. Are you talking about 5 millimeters? Are you talking about 5 miles? Are you talking about 5 kilometers? It makes a real difference when we're doing experiments and when we're talking about the natural world or labs, what our units are. So we have to use standard units, and that is also why we use the metric system, or SI, in science, so that we're using the units that the rest of the world uses. So centimeters, meters, kilograms, grams, liters, milliliters, stuff like that. And then weight, the metric unit for weight is newtons. So coming back to the question, let's revisit it. Why is it important that scientists all use a standard weight unit, the Newton, instead of different units like a special weight unit? Well, you would want to start that out using the race strategy. It is important that scientists all use a standard weight unit, the Newton, because, and then you'll want to explain your answer, and make sure you use evidence from your lab. And a hint is data table 1, when we had the same object and it had different weights. All right, so if you have any questions, feel free to email me. And that is our lab, our first kitchen table lab, 1.2 weight and the spring scale. All right, I will see you for our next kitchen table lab.